let's go through review. Numbers 5, 6, and 7 on part 3. These are the doozies, especially 5 and 6. All right, for some value of x, we have a sequence 2x plus 1, x plus 11, 4x plus 5, forms the first 3 terms of an arithmetic sequence. Okay, so ignore the geometric stuff. We want to find the value of x. Now, we've done a similar problem for geometric, which is actually going to be number 6 here. I'm going to do arithmetic first. Now, in arithmetic sequences, we know to get from term to term, we have to add something called the common difference. Now, we need to figure out kind of like what is that common difference to find the x. Oh, that's going to be kind of hard because we have x. So here's what I'm going to do. Think about if we had a sequence that just said like 5, 7, 9, on and on. And you had no idea that what you were adding to get from term to term. You would take the second number minus the first number, which would give you 2. And then you could check here, you could take the 9 minus 7, and that also gives you 2, and then you know that that's the common difference. We're going to do something similar here. Right? I'm going to take the second number minus the first term. Now, that's just the common difference for the first terms. I need to solve for x, so I need to set up an equation. You should be able to assume that the common difference is the same going from the second to the third term. So I'm going to set this equal to how I find the common difference for the second term, which is taking the third minus the second. Now what I'm going to do is I'm just going to solve that equation for x. So over here I'm going to distribute this -1. I'm going to do that on both sides to start. So x plus 11 minus 2x minus 1 is 4x plus 5 minus x minus 11. Now there's just a lot of combining like terms here. So let's see, the left-hand side, x minus 2x is negative x plus 10, and 3x minus 6. I'm going to add x here, and as I add x, I'm also going to add 6 to both sides, save some steps. So 16 equals 4x, and when I divide by 4, I get 4 equals x. That was the first part of the problem, so at least I know what x is. So what that helps me do, now that I know what x is I can actually find the terms of the sequence. So my first term is 2 times 4 plus 1. I'm just putting 4 in for x. Same here on this term, 4 plus 11, and 4 times 4 plus 5. Which if I simplify those, this will be 8 plus 1, which is 9, 15, 21. And then the sequence keeps going. All right, now it says, now that I know the sequence, I can find the numerical value of the 15th term. That means find a sub 15. Well, I actually have all the information I need now. I know the first term. I can find the common difference here. It looks like I'm adding 6, and n is 15. So I just have to type that into my calculator. 9 plus 6 times 15 minus 1. And that term is 93. If you need more help on that one, ask your teacher. But that's how we would do this one for arithmetic. When you flip your page, we've done one like this on a warm-up before for geometry. Okay, same idea, different sequence. So I have a sequence 4, comma x, and then x plus 8. Now, instead of finding the common difference here, I want to find the common ratio. So the ratio here, when we found this for other sequences, say I had 4, 8, 16, remember you would take the second term divided by the first to get the common ratio. I'm going to do the same thing. Second term divided by the first. Now, again, I'm solving for x, so I need to have an equal sign. And you can assume that the common ratio here is equal to the common ratio between the next two terms. So I can take the ratio here would be x plus 8 divided by the term in front of it. Now, hopefully once you see that, it kind of is ringing a bell. And the way we solved this was to first cross multiply. I have x times x, which is x squared, equals 4 times x plus 8. I'm just going to solve that for x. So if x squared equals 4x plus 32, and what I'm going to do is I'm going to move the stuff from the right over to the left so that I have a positive x squared, and I can factor. Okay. So I'm going to factor that expression. So if x minus 8, x plus 4 equals 0. And then remember, sorry, we can use our zero product law here. That says you take each factor, set it equal to 0, and then solve for x. And this time I have two values of x, so it's a little bit more work. But I have x equals 8 and x equals negative 4. So we have the possible numerical values for the 13th term. So I'm going to have to do this twice. So we'll start with x equals 8 here. Because if x is 8, it's going to have a different common ratio and a different 13th term than if x is negative 4. So first of all, let's find the terms of our sequence if x is 8. The first term is always 4. X here would be 8. And then I'd have 8 plus 8, which is 16. Oop, I didn't even realize that that was the example I gave a few minutes ago. So if those are the terms of my sequence, r is going to be 2. So it's super simple then to find the 13th term. I'm just going to use the a sub n formula for geometric. So a sub 13 is going to be the first term times our common ratio to the 13 minus 1. And you can type that in your calculator. I'll just tell you here. It's 16,384. That would be one possibility for the 13th term if x was 8. Now I'm going to do the same thing here, but assume that x is negative 4 this time. So this time, if I wrote out my sequence, the first term is 4, and I had x, so here, and then x plus 8, so negative 4 plus 8 is positive 4. Well, for this sequence, it looks like r is going to be negative 1. So I can find the a sub 13th term. Take my first term times my common ratio to the 13 minus 1 power. When I type that in the calculator, I get 4. So two similar problems, two different sequences, a little bit more applying what you learned to a more abstract situation, but I know you guys will do great. Last problem on the review, number 7, part 3. Given an arithmetic sequence, I'm not even going to worry about these two guys. A sub 3 is 11, A sub 7 is 23. Find the sum of the first 38 terms of the series. Now that we know sigma, when it says find the sum, you can either use S sub n or you can use sigma. I do not care. Both of them work. First thing I need to do, though, before I decide which formula and which method I'm going to use, I need to figure out the first term and the 38th term and all that good stuff, and the common difference even. So let's start with, here's a sub 3, 4, 5, 6, a sub 7. So I have 11 here and 23. Now we have found common differences like this multiple times. If I start at 11, I'm adding d 1, 2, 3, 4 d's to get to 23. I'll simplify by subtracting 11, which is 4d equals 12. So d equals 3. That helps me because at least then I can find the first term. We always need the first term no matter whether we're doing sigma or S sub n. So if I'm adding 3 to go to the right, I'm going to subtract 3 to go backwards. So I'd be 8 and then 5. So I know a sub 1 is 5 now. Okay, so I know d is 3, a sub 1 is 5. That's going to help us. Now you have to pick your method. It doesn't matter to me whether you use sigma or S sub n. Either one is fine. I'll do S sub n first, and then I'll do sigma real quick, and you can choose which one you like better. If I'm going to use S sub n here, I know the n. Oh no, I know the n is going to be 38. I know the first term. I don't know a sub n, so I need to find the 38th term. Okay, so I will take the first term, which is 5, plus our common ratio times 38 minus 1. And that will give me 116. Now Now, once I do that, I now have enough information to find the sum of those 38 terms. I would take 38 over 2 times the first term plus 116. And when I carefully type it in my calculator, I get this. It's not a long process, but that is one method, that top right part here, to solve the problem. So that's method 1. You still have to do the stuff on the left no matter what. If you want to use sigma, then you would have to start. Remember, with sigma, I need a formula here. So I'd have to write the a sub n formula for this equation, which would take the first term plus 3 times n minus 1. And I would solve it for n, which is 3n plus 2. And that would go here after my sigma. Then I do know what I'm adding up. I would know that I'm adding from the first term to the 38th term. And then I can type that into my calculator, math 0, from term 1 to 38 of 3x plus 2. And I get the same answer. So you can see it does not matter what method you use, you will get the same answer. So use what you're comfortable with and use what makes you happy. All right, if you have other questions, ask your teacher for some help.